Two questions from alcohols, phenols, and ethers. Give reason. The carbon-oxygen bond length in phenols is less than that in methanol. That is the first question. Let us look at it. So the carbon-oxygen bond. This is the carbon-oxygen bond in phenol. That is 136 picometers. Whereas in the case of methanol, it is the carbon-oxygen bond is 142 picometers. We are asked why the carbon-oxygen bond length in phenol is less than that in methanol. We can see here that this oxygen is attached to a carbon on the benzene ring. A benzene ring means there are pi electrons, or it's an electron rich system. So the electrons from this oxygen, that is the lone pair from this oxygen, can come in here, giving this bond a slightly, this can get a double bond character because of these electrons coming in here. That is the lone pair of electrons coming here, and a double bond character is obtained for this bond. Now why are these electrons coming in here? It is because of the presence of these double bonds on the benzene ring. That is the conjugation of lone pair of oxygen with the aromatic benzene ring. So what happens if it gets a double bond character? A double bond is stronger but shorter than a single bond. So the first reason can be given as, this is for A. The first point is partial double bond character due to the conjugation of lone pair of oxygen with the aromatic ring. So that is the first reason, is this transfer of these electrons here and creation of a partial double bond character here. Double bonds are shorter than single bonds. Next reason is, you know that this carbon here to which that oxygen is attached has got an sp2 character. It is an sp2 hybridized carbon to which that oxygen is attached. Now what is the speciality of sp2 hybridized carbons? They are more electronegative than sp3 carbons. Here in the case of methanol, this is a single bond, and this oxygen is connected to this carbon which is sp3 hybridized. sp3 hybridized is not as electronegative as sp2 hybridized. In sp2 hybridized, S character is more. So that is why it is behaving as a more electronegative entity. So now what happens if it is more electronegative? It will pull the shared or the bonded pair of bonded group towards itself. Thus it will create a shorter bond, or the bond length will be short. So next reason is sp2 hybridized state of carbon to which oxygen is attached. This is in the case of phenol, leading to a stronger attraction for the bonding electrons and a shorter bond with oxygen, and a shorter bond with oxygen. So in the case of methanol, that is not that. This is an sp3 hybridized carbon and it is a normal single bond. So that is why the bond in phenol, the carbon-oxygen bond in phenol is only 136 picometers, whereas the carbon-oxygen bond in methanol is 142 picometers. Here the carbon is sp3 hybridized and there is no option for these electrons to come in here because there is no double bond here or other electrons here to which there can be a conjugate effect. So that does not happen here. So that is why this carbon-oxygen bond length is phenol is less than that in methanol. The next part of the question is the carbon-oxygen-hydrogen bond angle in alcohol is slightly less than the tetrahedral angle of 109 degree 28 minutes. So this bond angle, the carbon-oxygen-hydrogen bond angle, this is only 108.9 degrees, whereas the tetrahedral bond angle is 109 degrees 28 minutes. That is because of the presence of lone pairs on oxygen. The repulsion between the lone pairs on oxygen will force these bonds closer, thus resulting in a lesser bond angle than the normal tetrahedral angle of 109 degree 28 minutes. So here the bond angle is only 108.9 degrees. So the reason we can give as the bond angle in alcohol is slightly less. That is B part of the question. The bond angle in alcohol is slightly less than the tetrahedral angle, due to the repulsion between the lone pairs of electrons, on oxygen. So this bond angle is lesser than the normal tetrahedral angle because the bond angle, tetrahedral angle, due to the repulsion between the lone pairs of electrons on oxygen. So these lone pairs will push the bonds closer together. So that is why the bond angle is less than the normal tetrahedral angle.